Ever wonder how a jet engine actually works? It's like a giant vacuum cleaner, but instead of sucking up dirt, it pulls in air to create thrust. Let's break it down step by step. First, the engine takes in a massive amount of air through the front, just like a vacuum collects dust. This air travels through a series of fans and compressors. These compressors are like a series of increasingly narrow tunnels that squeeze the air tighter and tighter, making it denser. Now here's the surprising part. As this compressed air moves deeper into the engine, it encounters fuel that's mixed in. Think of it like adding gasoline to a campfire. When the fuel and air mix, they ignite in a combustion chamber, creating a burst of hot gas. This explosion pushes against the back of the engine, just like how air blasts out of a balloon when you let it go. The force of the gas rushing out is what propels the plane forward. In fact, this process is so powerful that jet engines can push thousands of pounds of aircraft into the sky. And here's something reassuring. Jet engines are built to be incredibly reliable. They undergo rigorous testing and maintenance to ensure they can perform flawlessly. In fact, modern jet engines can run for thousands of hours without any issues, making flying one of the safest modes of travel. So to answer the question, a jet engine works by pulling in air, compressing it, mixing it with fuel, igniting it, and then pushing the resulting hot gas out to create thrust. It's a remarkable piece of engineering that gets us safely across the skies. If you're curious about more aviation secrets, don't forget to subscribe. So, how exactly does a jet engine work? At its core, a jet engine is like a big, powerful air pump. It takes in air from the front, compresses it, and mixes it with fuel before igniting that mixture. Let's break that down step by step. Imagine blowing up a balloon. You start by taking a deep breath, filling it with air. That's similar to what the jet engine does. It sucks in large amounts of air through its front intake. This intake is designed to gather as much air as possible, like a funnel. Now here's where the magic happens. Once that air is inside, it gets compressed. Think of this like squeezing that balloon. When you squeeze it, the air inside gets packed tighter and tighter. In a jet engine, this compression happens in a series of spinning fans called compressors. They spin incredibly fast, compressing the air to a fraction of its original volume. This makes it much more efficient for combustion. Next, this high-pressure air enters a combustion chamber, where it meets jet fuel. Imagine mixing gasoline with air to create a mini explosion. That's what happens here. The fuel is sprayed in, and when it ignites, it creates a rapid expansion of hot gases. This is the explosive part that everyone hears about. As these hot gases rush out the back of the engine, they push against the air in front. This propulsive force is what drives the airplane forward. So in simple terms, a jet engine takes in air, compresses it, mixes it with fuel, and ignites that mixture, creating a powerful thrust that pushes the plane ahead. And just like that, you understand the basics of jet engines. Curious about what happens next? Stick around, because we're just getting started. Ever wonder how a jet engine actually makes the air it breathes more powerful? Picture this. We're using a bicycle pump. As you push down on the handle, the air inside gets squished tighter and tighter. This compression makes the air denser and in turn more powerful. Now, let's connect this to a jet engine. The first section of a jet engine is called the compressor. It works just like that bicycle pump. As air enters the engine, the compressor blades spin rapidly, forcing the incoming air to compress. This process raises the air pressure and temperature significantly, turning that cool, ambient air into a denser, more energetic form. And here's the surprising part. By the time this compressed air reaches the combustion chamber, it's packed with potential energy. In fact, the air temperature can soar to hundreds of degrees. This is crucial because when we introduce fuel into the mix and ignite it, that compressed air reacts more efficiently with the fuel, creating a powerful explosion. This explosive force is what pushes the aircraft forward. So, without compression, you wouldn't have the same power to get that airplane soaring through the sky. It's this cycle, compression, combustion, and expansion, that's at the heart of jet propulsion. In summary, the compressor in a jet engine is like your bicycle pump, turning ambient air into a potent force that fuels the engine. Next time you're on a flight, remember how vital that compression is to getting you safely from one place to another. Curious to learn more about how the rest of the engine works? Stay tuned. After the air is compressed, it enters the combustion chamber, and here comes the magic part. Fuel is injected into that high-pressure air. Think of it like pouring gasoline onto a campfire. The mixture of air and fuel ignites, creating a powerful explosion that expands rapidly. Now, let's break that down. When fuel mixes with the compressed air and ignites, it produces hot gases that want to escape. This rapid expansion is similar to how a balloon pops when too much air is forced into it. In a jet engine, instead of bursting, those hot gases are channeled out through a narrow nozzle at the back of the engine. Here's the surprising part. This combustion process not only produces thrust, but also helps drive the engine's turbines. As those hot gases rush out, they spin the turbines, which are connected to the compressor at the front. It's a continuous cycle. Air gets compressed, fuel is added, ignited, and the resulting gases push the engine forward. This whole process happens incredibly quickly, with the combustion occurring every few milliseconds. It's a bit like a rapid-fire series of mini explosions, each contributing to the overall thrust that propels the aircraft through the sky. So in essence, the combustion chamber serves as the heart of the jet engine, turning fuel into motion with remarkable efficiency. And that's how fuel and air come together to power your flight. Ready to see how those hot gases propel the plane? Stick around. So what happens after the hot gases from combustion? They rush through the turbine, and here's where it gets fascinating. Think of the turbine as a giant windmill. Just like a windmill spins when the wind blows, the turbine spins because of those super hot gases pushing against it. Now here's the surprising part. This spinning turbine isn't just for show. It's doing real work. As it spins, it generates energy. This energy is crucial because it powers the compressor we talked about earlier. That's right. The engine is set up in such a way that it creates a self-sustaining cycle. Imagine a bicycle with a dynamo. When you pedal, the dynamo generates electricity that can power your bike's lights. In the same way, as the turbine spins, it creates enough energy to keep the compressor working, pulling in more air and repeating the process. This clever design means that once the engine is running, it continues to operate efficiently without needing external power. The gases from combustion create the energy to keep everything moving. It's like a perpetual motion machine, but of course, it's all rooted in the laws of physics. And here's the reassuring part. This system is incredibly reliable and has been honed over decades of engineering. Jet engines are built to withstand extreme conditions, so they can safely power us through the skies. Now you know how the turbine plays a crucial role in this impressive cycle of energy. Next, we'll explore how all these components work together to give us that amazing thrust we feel during takeoff. You might be surprised to learn that despite how complex jet engines are, they are designed with multiple backups and redundancies. This might seem counterintuitive. How can something so intricate be so reliable? Here's the reassuring part. Jet engines operate with incredible safety measures that make failures extremely rare. Imagine a car with multiple safety systems. If one part fails, there's always another ready to step in. Jet engines are built the same way. For instance, they have multiple fuel pumps and igniters. If one system has an issue, another kicks in. The engines can even continue flying safely on just one, which is a crucial safety feature. In fact, modern jet engines are so reliable that accidents are incredibly rare. Statistically speaking, flying is one of the safest ways to travel. To give you an idea, you're more likely to win a small lottery than to be involved in a jet engine failure during a flight. So how does a jet engine actually work? It compresses air, ignites a fuel-air mixture, and uses the energy from this combustion to create thrust. This process is seamless and efficient, combining advanced technology with rigorous safety standards. It's pretty amazing, right? If you enjoyed this explanation and want to learn more about aviation insights, consider hitting subscribe. You'll never look at a plane the same way.